Hey everybody, welcome back to the Air Cave Shop. I'm Dean. So, as you probably saw from the description, I'm going to add a power feed to the Bridgeport mill for the table. And it's been something I've been wanting to do for quite a while. And also, I've been working a little bit with VEVOR, and they have a power feed. So I asked if, hey, you want me to do a review on it? So yeah, so they sent me one. It's a very affordable unit, and we're gonna do like we normally do. We're gonna call it like we see it. If there's a problem with it, if it's no good, we'll let you know. If it works out good, fine. So let's go ahead and get the box open, take a look at it, and then we'll get going on the install and the test. Well, it showed up in good shape. No real damage. The box is not that heavy, which is a little surprising. So anyways, let's get her opened up. Oh, by the way, it did ship locally. It came from Southern California. That's about 330 miles south of me. Okay, let me give you guys we go handheld, give you a close-up here. All right, we got everything opened up. Let's look at the power unit first. So, I mean, the finish and so forth looks very nice. And it's very typical. I think most of these come out of the same factory, and it is China. I do see a couple little burrs left in here, no big deal. But yeah, overall, that looks pretty good. The handle feels pretty positive. Speed control is here, and I'm assuming that's the rapid. And then you got an on-off switch down here. Okay, power cord looks fine. Here's the limit switch, and it's got this little cover. Coolant protector cover, so apparently it just moves the whole cover when the switch activates. Okay, here's the limits, and these go into table stop slots. Okay, we got a little safety plunger. I guess that's to give it a little bit of cushion to allow for the motor to wind down. Check this out. Hopefully that was in frame. So I looked at this and go, is that square? No. So they're both the same issue. And I did check this over on the mill. They do fit the slot. But yeah, they're not square. So I'm guessing this plastic probably had some type of stress or shrinkage, probably shrinkage when it came out of the mold. So it wouldn't be hard to duplicate these out of aluminum. And I was looking online, and most of them use this. In this price range, they use the plastic ones. Here's the mounting plate. Not too bad. It's got a hollow back. There are a couple blemishes here. They're not going to hurt anything. All right, and here's the drive gear. Looks good. I'm not crazy about this plastic nut, but I noticed they all use this. And I think even the Taiwan models, well, maybe not, have this plastic nut. So it is what it is, okay? Parts kit, pretty basic, just some shims, screws, and so forth. So we're ready to start our install. The first thing we got to do is remove our handle and our dial from the mill. So let me move things around and we'll get that done. But we've got an issue with the keyway, and this seems to be a common issue with these particular power feeds. So the key is the right width, but the keyway here Actually, I should say the keyway is the right width, but it's not deep enough. Yeah, so the new gear and hub will not go over that key, okay? But we've got another issue. All right, I'm going handheld. This will be easier to point out. So normally you want to put the power feed on the right side of the machine. Most of us are right-handed. See this bearing retainer plate here? That's holding this side because it's the thrust bearing side. Okay, so this side just has a plain bearing. So either when I did the refurbishment of this mill, I may have got them backwards, or maybe it was that way and I just put it back the way I found it. But either case, I need to flip-flop these. So okay, this is the side where we want to put the actuator, but it's the side that had the thrust bearings. And here's the sleeve that goes in the bearing of the power feed. And notice the difference in the length of this race. Okay, this is the side that it's supposed to go on. All right, so what I got to do is flip-flop our lead screw. I'm going to do that off camera. I think I can just unscrew it all the way out, flip it around, and screw it back in. Lead screw is out, and just giving it a check. It's in excellent condition. There's what it looks like underneath, and all I did was just a quick wipe down. I mean, this machine is not a daily driver, so it only gets hobby use. It gets babied. All right, I got the lead screw back in, turned around the right way. Got our thrust bearing and support block back on, handles back on, and so forth. So we're all good there. I do have a confession to make. So while I was working on it, I noticed I had stamped these, that one with the letter R, and this one's got a letter L underneath, so that was my bad. When I put this together last time, several years ago, I got them wrong. Okay, let me take you around to the other side and let's see what we got. First thing I did, I moved the table that way so that we had less lead screw hanging out in the breeze here, so it would be more solid, okay, and stay in alignment. And then I went ahead and put our mounting plate on. There's no rocket science there. The negative thing is we don't have the alignment pins in this plate. So let me show you how I lined it up. And I think this is pretty critical. So what I did is I got the plate on here, and then I put the actuator on. And it does have pins. We just went into the pins, okay? And I put in our two mounting screws. All right, so then using the calibrated eyeball micrometer, I loosened up our mounting screws and moved everything around until our shaft is dead center in the actuator. Okay, next is this bearing race sleeve. Okay, it's very hard to get this on with the actuator in place, so I found it's much easier to do it with it off. You've got to get it started nice and straight because it's a close fit. Okay, there you go. Now I don't like how easy it turns. I mean, I can't feel any play, but I mean, this is a bearing race, and the actuator has a bearing, you know, exposed bearing that rides on this. I'm almost tempted to put a drop of Loctite just to keep this from spinning. Yeah, I don't know. In fact, you know what? I think I will just put a little tiny drop. My next concern, and I may be just totally anal on this and overthinking it, but there's a little undercut right here, on the shaft just before the bearing diameter. And the shims that go on next, well, we have to put the actuator on first, but the shims that go on after that, they're a little loose on this diameter, not real bad, but they're going to sit in here where this undercut is. So they're not going to stay centered very well. But I think we're past the bearing area, so I think we're okay. It's just kind of weird in my opinion. The other thing is this bearing sleeve is a little bit shorter than the bearing turned area. So when these little washers are going to be, they're not pushing against the sleeve. There's a little gap here. I don't know if you guys can see that. There's a little gap, probably, 100 thousandths between the shim washer and this bearing sleeve, which I would rather have seen it actually make contact with the bearing sleeve. I don't think it's the end of the world, but it's just, one of those things that's like, why, right? Okay, let's try her again. Okay, before we start getting into figuring out our shimming, I want to address this key issue. So there's a keyway in here and a woodruff key in our lead screw shaft, and they're not the same size. Let's go over to the bench and we'll have a closer look at it. This is the woodruff key that came out of the lead screw, and it's a standard imperial. It's a 1/8 key, okay? Now our keyway in the adapter here, it's not 1/8. In fact, it looks like it's 3 millimeter. I've seen other guys, they'll file the keyway down or the key down to get it to fit, but then it's going to be loose in our handle because it's got to fit both. I'm going to see if I got a broach where we can just rebroach that. I think that's a better way to do it. I would rather keep the original parts original. So let me take a look and see what I have. Alright, well the good news is I got a broach and a guide bushing. I'm a little weak in the shim department. I'm going to have to make a couple new shims. And this guide bushing, the slot is not deep enough, so I'm going to have to mill that down a little bit. Alright, more work to do. Okay, I cleaned up the slot on our guide bushing. Only took about 8 thousandths out of it, that's all it needed. And I made a couple of shims, so we're ready to broach this thing. I've been fine-tuning our spacers that go between the drive unit and our gear. And the book or the instructions say to shoot for 2mm. And let's see what we have. And I tried 2mm. It was a good starting point, but I was not happy with the amount of backlash we were getting. Okay, so I'm at 1.73mm, and I'm happy with this setup. So it's got, I don't know if you can hear that. It's got just a little bit of backlash. No, more than a little bit. Just, I'm going to call that the optimum amount of backlash. Checking it in a few different spots. Okay, so that's what we're going with there. So while I'm checking shims, I figure I'll go ahead and check the fit of our dial. So they only gave me in the kit one of these shim washers for our dial. Okay, so put it on there. It's not enough. So I already did the calculation. I need another 30 thousandths to give us the clearance we need so our dial doesn't rub. Okay. They don't give you enough shims, so I've got to make a shim. I suppose I could call them and wait for tech support to hopefully send me some more shims, but I've got shim stock. It's going to be a little tricky to get that cut perfectly, but I think that's the way I'm going to go. Another little frustrating item. Not exactly what I was planning on it doing, but I think it's going to work. Well, that saved me having to worry about releasing the super glue. But our little shim washer spacer thing turned out pretty good. Oh, and it even fits. Look at that. All right. Okay, I think that's the last custom part we need to make. Okay, hopefully this is the final assembly. We've got our spacer washer shim in there. I put some fresh grease on our gear since we had it on and off so many times. Our key is in place. So this goes on now. That's a really nice fit. Sure we're engaged. That feels good. Okay, now we need the new shim washer spacer thing that we made, plus the original. Let's go there. Our dial. And we have clearance. Do not like this plastic nut. We're going to be making one of those, or we might cheat and see if we can buy a replacement nut for an imported mill. That's a 1.25 metric thread pitch. Okay, that seems to work. All right, let's put our handle on. Tell you what, we're going to need another spacer. We're still dragging. Dang. All right, well, let me check that and do that off camera. If I loosen up our lock nut, yeah, then it's fine because we don't have any tension. Wonderful. I've had these parts on and off at least a half a dozen, I'll make that a dozen times. Hopefully this is it. I didn't need to take this off again, but I don't think I showed how that keyway came out after broaching it. It came out really nice. All right, our other shims are already on there. That fits really nice. Okay. So off camera, I made a new spacer washer ring thing. I just made it one piece out of some bearing bronze. That previous one, trying to make that out of shim stock was not easy. Okay, so now our dial goes on. I'm going to leave this washer off because we don't have a lot of thread, so, and this nut has a good finish, so it shouldn't gall anything up. Okay, that's perfect. Brought you back around to this side. Now with everything tight, I'm just checking our backlash again. Got it in gear. Got about just over 1,000th on the dial here. You can see how much the handle's moving. So we have backlash. Tried a couple different spots. Okay, I got 2,000ths there. It's hard to feel the difference between the actual drive gear backlash and the motor backlash. Okay, that's about 2,000ths over there, so I'm happy with that. It turns freely. Okay, time for electrical. I hate to lose my table stop. I use that quite often. Well, it's pretty easy to put back on, so I guess it is what it is. I think I'm gonna grab a couple washers. Let me do that. Nope. Time to file. All right, success. We got the switch mounted. Much better. All right, I took out one of my way cover screws here, and I got a longer screw. They gave us this little clip. I did a little test here. It doesn't even grip the cable, and it's really thin. So I went to my stash and found a better one. This one actually grips the cable. Okay, I've got to leave a little bit of a loop here to clear the table lock. Okay, I got the table stops in, and check out this precision alignment. I can get you guys aimed here properly. It'll be better when the cover's on, but oh, that's not good. I'm going to make new ones of these anyways. These are not adequate. Okay, so these springs are meant to go in here. It's going to be fun trying to figure out how to get them both in there at the same time. All right, here we go. That one feels like it's in there. Woohoo! Okay, I think that's got it. Okay, I think we're finally ready. We're plugged in. I'm just using an extension cord for now. I've got to devise a permanent, some type of power strip, because I'm going to be adding a DRO here at some point, so I'll need a few spots for plug-in. Okay, so we're in neutral, power on. We've got a light. Let's see if she'll feed. Let's see, turn our speed all the way down to 0. Slowly bring it up. Okay, we're moving. Just let it go ahead and hit our limit here and see if that works. Seems pretty smooth. Okay. Now can we go the other way? Yep. All right. You speed up a little bit. Let's try the rapid. Okay. Coming up on the limit. Okay. All right, let me bring you in a little bit closer. Okay, one thing I noticed right off is there's a safety issue. I actually noticed this earlier. Let me turn the power off. So the clearance between the handle and the body here is really close, especially on the counterweight end. So if you weren't paying attention and you got your hand in here, or your fingers, that could be pretty painful. This is 150 inch-pound, and this is 3 inches from here to here. Same on the other side. So let's see, what would that be? 37 pounds of pressure. Of course, you got the momentum. I don't know if that would break a bone, but it's certainly not going to feel good if you accidentally got your hand in there. So that's kind of something to be aware of. All right, so let's continue with our testing here. Okay, that way. Let's see how slow we can go. Okay, that looks like that's probably it right there. Looks pretty smooth. Now what happens if I put some pressure on it? It slows a little bit. Let's go a little bit faster. It's pretty touchy right here at the bottom end. It still seems pretty steady, even putting some back pressure on it. And it does slow. But at least it's not herky-jerky. Let's try a little faster. Yeah, so it does slow down when you put some pressure on it. I'm putting quite a bit, okay? Alright, so we'll have to see what that does when you're actually cutting. Okay, now let's go the other way. Let's see where we hit maximum speed at here. Okay. The speed adjustment seems pretty good. Well, we reached full speed about 3/4 of a turn on the knob. At least that's what it seems like. Clutch disengages pretty quick. Yeah, and this is my first ever power feed, so I'm not a good judge as to how smooth and so forth they're supposed to run. This was our block with the super glue. Should be a good candidate. Okay, let's see what happens. let's take 10 thou. I've got the feed rate not as slow as it'll go, but pretty close to the minimum. That's pretty nice. Boy, that looks pretty good, guys. No complaints here. Well, that didn't exactly just bolt right on, did it? So that was a little bit of a challenge to get everything set up and so forth. So let's review what we did here. Well, first of all, these are the leftover parts, or the parts that are no longer needed on the mill. And I'll put those in a safe place, because if we have to go back to manual handle, if I need that full travel, or if I want to use the table stop, not that difficult to switch back. And now that everything fits, okay? So, and then these are the parts left over from the install kit. The instructions, I mean, they're definitely not 100%, but they're not bad. I mean, you're not going to do one of these without some skills anyways, you know, so, you know, this is going to be the machinist putting this on, or, you know, the hobbyist DIY type person that's going to be able to figure stuff out. So, I mean, it is what it is there. A couple of issues that we ran into, the bearing race, the little sleeve. So there really wasn't a way to secure that, and I think some of the other kits, you know, the more expensive kits, they give you a spacer where that race will be secured when everything's tightened down. I used a little bit of Loctite on that race to keep it from spinning. I don't know if that's advised or not, but that's how I did it. Okay. One thing that's not in the instructions, well, let's just double check here. No. When you put the adapter plate on and the drive motor, you've got to make sure you get it lined up to your lead screw. So that's an important step. You don't want to have anything binding there. And then the other big issue was the keyway being the wrong size. Now bear in mind, my Bridgeport is 1963, and they may have changed a few things along the way. But more than likely they modeled this kit on probably a clone, an import clone style, knee mill Bridgeport style, which may have had a metric keyway. So we had to broach that out. We could have tried the keyway filing method, but I think broaching it to full size is probably the better way to go. And then the other disappointment was this: they didn't give us enough spacers for the dial, and ended up having to make our own. Which there again, if you've got a machine shop, you can do that kind of stuff, but it's just something else you got to do. Not really crazy about the plastic nut for the dial, but it works. And after we run this for a while and everything seems good, I'll probably just go ahead and make a metal one. The limit switch stops being made out of plastic, those are pretty cheesy. And I'm definitely going to remake those, probably out of aluminum. Yeah, so, and this is the lowest cost power feed you can get, at least that I found, just poking around on the internet. Compared to, the official servo brand, you can buy like 6 of these, maybe 5, for the same price as one of those. But you're going to have to go through some pain to get it installed, to get all the adjustments and everything worked out. For a production shop, professional shop, you probably can't screw around. I mean, you got paying jobs, time is money, and you need the reliability. You're probably going to just get the genuine servo brand. There is kind of a middle of the road one that's about, I think they run like $350, maybe $400. Maybe they're a little better, but anyways, you got to make your own decision. The unit itself seems to be pretty good, and what I'll do, I'll run this thing for about a month or so, run it through its paces, and I'll come back and we'll do another quick video update to let you know how it's doing. Okay, and then our finish. Yeah, I mean, it ran consistent. It might do a little better with like a servo brand or the other mid-range brand, but geez, I'm happy with that. It did a good job. Video's pretty long. I'll try one in steel, which is going to have a little more resistance. Although we did take a 10,000th depth of cut. So, all right. Well, anyways, thank you VEVOR for letting us review that. And I'll put a link down below. I believe it's an Amazon link for the product, and I'm not sure if there's a discount code, but if there is, I'll put that down below also. All right, thanks for stopping by, everybody, and we will see you on the next one.